Hi, everyone. I just wanted to go ahead and re-record this tutorial on processing data for experiment 9. The new plate reader that we're using during this construction period formats the data a little differently than the previous system did. I think it's all a software default. So I'm going to go ahead and show you that there really is no difference between the data being sort of more horizontal or being vertical like it was in the past. You do the same things, but you just have to do it in a different direction. And I'll show you how to do that. But I want to go ahead and first show you, first thing I do, and anytime I have a data set that I'm processing, I will color code everything. And so that the standards, and I will, since they're kind of yellow, make that yellow. And this is the wild type, and I think maybe making that light blue and make mutant light green. Yellow plus blue is green. It doesn't matter. Just color code them, and I color code them just so that I know which ones are which, and I can visually see things. Now, the first thing I want to do is standard curve. The concentrations are start off at 250 micromolar is equal to this value divided by 2. Hit enter. And then we'll go ahead and copy that equation all the way down. It'll do serial dilution for us. Take that value, divide by 2, and so on like that. Now, and we'll do is call that concentration of standard. Okay. Next thing I will do is go ahead and do standard absorbance. I always like to go ahead and label things so that I know what I did and what I'm doing. And so that's standard absorbance. ABS stands for absorbance to me. Now the absorbance, what I do here is to help make the data look a little better, I take the mean of these three values and take the mean of those three values, put an equal sign, type AVER, double click on that, highlight those three values, hit enter. And so the mean comes out at 2.84. And you see all these values. And if you ever need to change the values or anything like that, you can make more decimal plates by playing with these values. If you get 4 decimal places, you kick right here a couple of times, it'll do that. So just figure out what you want to do that way. It doesn't really matter too much. Because it will calculate everything based on all those values. So Excel's kind of nice that way. You can see it one way, but it uses all the values, which to me is a good thing. So now I highlighted all these areas, so I have all the concentrations and all the absorbances highlighted. I'll do insert charts, the XY scatter, and do an XY scatter chart. What I know is I'm going to have to move this way over here because of things I want to do. Later on, we'll move it all over here. And you see, it looks like the line looks pretty good, but let's go ahead and see what it looks like. Add trend line. Go ahead, and I like to remember the equation and R squared, because I like to see those values. And the R squared is excellent at 0.9984. It's a little bit off the points, but it looks pretty good. So overall, the standard curve looks good. But if you remember, I don't like to type in these values because I like to be able to change things. And if I need to change the standard curve or anything like that, so I go ahead and I calculate the y-intercept. And I go ahead and also calculate the slope. So I'll put those in. So here for the intercept is equal to, Excel has the term intercept. And the intercept, if you notice here, it says known y's and known x's. You'd have a tendency to do it just the opposite direction. But let's put the y's in. But these are the results, so that'd be the y. And then we'll go ahead and type in the x values and hit enter. Why did it hit that? Oh, okay. If you have a mistake like that, it only did that, just go ahead and put all these values in like that, and you can fix it that way. So the intercept is 0.05, and what do we get here? 0.049, around it, just that's the same number. Slope, we'll go ahead and hit enter. Equals, start typing slope, double click on that, and it also has known y's and known x's. So x's, remember, are going to be the independent variable, and the y's are your dependent variables. So go ahead and type that in. We'll do all the y's, comma, all of the x's, hit enter. We have 0.01. For some reason, I don't know why it's doing this, but it's making really small number decimal places for you to use. So I just go ahead and keep going up here to do that. So we now have those two values calculated. So we have our standard curves. We have these two values that we'll be using to determine the concentration of product for all of these reactions. So let's go ahead and here type average absorbance, and we'll go ahead and put the mean in for, and that's going to be wild type. And we'll go ahead and put it in equals average, and highlight those three values, hit enter, and now we'll drag all the way across this way. But what I haven't done yet is I haven't determined my x values yet. And we'll have to do that because it was also done by a serial dilution. Your first value was 20 millimolar. Your second one was a twofold dilution of that, so it's equal to this divided by 2, just like we did in the other standard. And we'll go ahead and copy that across this way. Okay, so we have these values. Now I want to go ahead and determine, that's the average absorbances. So from that, I want to be able to determine the concentration of P and P produced by these individual points. So I will put in wild type concentration P and P. So that's the amount of product made. And if you remember in the past, we've done this calculation. Remember, the fitted line is y is equal to mx plus b. B is the y-intercept. M is the slope. And to be able to calculate x, it's y minus b divided by the slope. So we'll go ahead and put that calculation in. Now, a couple people told me that some versions of Excel, you actually have to put more parentheses in it. So if you get values that look really unusual, you might need to do it. Just remember that Excel uses the PDMOS thing where it does parentheses, exponents, division, multiplication at the same time, and addition and subtraction at the same time. So it'll do all the unit operations will be in that order, and they'll always go from left to right. So we'll go ahead and put in equals, and I like to go ahead and I want the subtractions to be done first. So it's the y value minus the intercept. And remember, we're going to do the calculation. We don't want it to move in a relative position, so we have to put dollar signs in to fix it in place. And then we'll close the parentheses, hit divide, and then we'll divide by the slope. And we don't want that to move, so we'll put dollar signs in front of the two elements of the cell reference. There. So we see we have 145, and we'll go all the way across like this. Well, we're going to be doing Lineeaver-Burk plots. Oops. So I want to go ahead and I may as well go ahead and calculate all these things out at the same time. So it's 1, oops, we'll type it as, here is 1 divided by wild type PNP concentration. So go ahead and put that in there, and equals this value, oops, I jumped the gun, 1 divided by this value, hit enter, and we'll go ahead and copy those all the way across. It should go from a bigger number to a smaller number, and it's odd here. I'm not sure why this is happening, but the number of significant figures keeps changing. So we have these values. So notice this is smaller. This was the bigger number. Now it's a smaller number. The smaller number is now the bigger number. Okay, so we've done all of those, and I'll go ahead and since we're going to be doing that, I will go ahead and type that in blue. It's a slightly different color blue. It's darker, so I know it's a little bit different. So the next thing I'm going to do is do all these calculations again, but I'm going to use the mutant version. And so it'll be the mutant. So it'll be average absorbance mutant, M-U-T. Okay, and I will do that. And it'll be equals average. Double click on that. Highlight these 3 values, hit enter, and we drag those across to copy them across. And what I'll do is I will make those green. Now, to calculate the total number of moles, so that'll be mutant concentration of PNP produced is equal to, remember it's y minus b divided by the slope. So we'll go ahead and put these in parentheses because we want that math, the subtraction done first. So it's this value minus this value. And we want to keep those fixed in place. So we have to put dollar signs on each of the cell references, on each aspect of the cell reference. So close that parentheses here, and we'll enter slope. We want to fix that in place, so we have to do the dollar signs in front of them. We'll drag that across, and that just copies all those values. Excel's kind of nice that way. It does a lot of sophisticated math and math really fast for you just by copying across. 1 divided by mutant, oops, I like that to be in lowercase, PNP, close that off. So the mutant constant, the concentrate, the 1 over the value, so it'll be 1 over that value. I will go ahead and put an equal sign. 1 divided by this value, which is the 20 millimolar version, and we'll copy that all the way across. And what we'll do here is, just to make things look a little bit better, we'll go ahead and add more significant figures, that in there. So now what I'll do here is the screen. I'll make it one a little bit started. So now I have all the calculations that I need to be able to get my Lineeaver-Burk plot. I won't be able to do the intercepts yet, but this will be the values that I'll use. So go ahead, and one thing I want you to do is to do a Michaelis-Menton plot. So to do that, highlight these areas. Let's go ahead and highlight all of these right here like that. Go Insert, Charts, XY Scatter. And you see it looks kind of almost like a straight line. That's good. But, in reality, I don't like that one so much. What I'll do is I'll just hit the little delete key and go ahead, insert, XY scatter, and I'll go ahead and put the line in it. So make it look like that. So I can see what that shape looks like. So this is the Michaelis-Menton plot. And in reality, I made a mistake. I went ahead, and even though the graph will look just the same, let's go ahead and delete it. What I Okay, there we go. So we go ahead and highlight only those areas, and we'll put in some of that information a little bit later. So we have that. So we know this one, the blue is going to be wild type. Let's go ahead and the same graph, while we're thinking about it, go ahead and put the same mutant data in. So we go to the select data button in Excel here, and we see that that's called series 1. Let's edit that and click this thing here, and we know that it's wild type PNP concentration. And we have all those values, so hit OK. So we now have that graph, so this is wild type. Now let's go ahead and click add. We'll hit that, and we'll put this value for the mutant PNP. We'll type this one, which will be this value here, all the x's, the independent variables, and we'll click this, and we'll put in the dependent variables. Hit OK, and OK, and you see there's 2 lines. So we'll go ahead and call this Michaelis-Menton results. So we have that. So let's go ahead and move this over to here. So we have that graph. And I always like to look at those, and that'll be something you put in your report. So this will be from the first replicate. This will be the first time. I think this is, I'll ask you to do them all in duplicate. So you're going to have to kind of do this 2 times. But if you go ahead and lay out this equation right, you can copy and paste all that data in and get all these graphs pretty easily. But let's go ahead and now let's do the Lineeaver-Burk plot. And here, one thing we haven't prepared for is the Lineeaver-Burk plot information. And we do the reciprocals of those concentrations, which we hadn't done. So let's go ahead and do them. Divided by this value, hit that enter, and just copy that all the way across. So this is 1 over substrate concentration. And make that a capital S. And this is, and I usually go ahead as I'm doing it, I label these things, because if you don't label them, you will forget. And here we go, we have the reciprocal values. So now let's go ahead and do the Lineeaver-Burk plot for wild type. So we'll highlight the independent variables, the x's, and then we hold the control key down, or the command key in the Mac, and highlight all the reciprocals of the resulting velocities. So we have those 2. We'll go here and go to Insert, Charts, and do this value. So I like, because we're going to be putting a trend line in, I didn't have it draw all the lines here. And that's why I did that. So we have that, and we have this. Let's go ahead and hit that. Add trend line. We'll add the trend line. Display equation on the chart, R squared on the chart. Another thing is, if we want to, I always like to see where the intercept is going to be. And you can use the forecast feature in this dialog box. So what I do is I kind of look at an experiment, see what looks the best. I think 0.2 will look pretty good here. and it hits right around that line right there, so it looks good to me. I think that looks good, so I will go ahead and tell that to go away. So I have that. And another thing that I do for a lot of these things, I'm going to do multiple equations, multiple trend lines on a chart. I will put the equation in that color. So let's go ahead and put that text in, go to home, here, make it blue. Oh, why didn't it work? Highlight it, make it blue, and it makes it blue. So we now have the blue line in the blue equation. And you'll see kind of why, how that distinguishes it. And we'll change that title. We'll do that momentarily. Now we have the mutant data in it. So now we want to go ahead and go to chart design. We want to select data. We notice it has series 1 in it. We'll go ahead and click the edit box. Click that. And we'll put this value in. Oh, sorry, this value in. So we know that was wild type. Next, we want to go ahead and add another equation in. So click add. We'll do this. Then we want to name that data. It'll be 1 over mutant. Click that little down arrow. Click this one. This looks for the x's, which will be, will be these values right here. And then we'll look for the y's, which will be these values. And hit enter. And hit OK. And hit OK. And we'll have another line here. So we'll go ahead, and this one's a little bit low, but we'll go ahead and look at it. Here, add trend line. We'll go ahead and display the equation and the R squared on the chart. We'll do a forecast to see where it's going to intersect. So backwards, I think 0.2 will look pretty good. So 0.2, hit that. Did that hit a little bit before the top? So that's probably close enough. I can at least see where about where it's going to intersect. And I use that to kind of make sure that all the other equations are right. So go ahead here, type Lineeaver-Burk. So we now know what it is. So now we have those. It looks pretty good. The fit's 0.97, 0.9, about 0.96. They're not super great fits, but they're reasonably good fits. And I wanted to show you this is realistic. They won't completely fit. You see that some of these are not quite on a line, so you kind of expect not great fits. And that's one of the reasons. Look at the Michaelis-Menton. We know this is all initial rate, because that is probably an approximately a straight line. Okay, and here we have the Lineeaver-Burk plot data. Next thing we need to do is I want you to calculate the kinetic values from here. And to be able to do that, remember that Vmax is equal to 1 over the y-intercept, so it's 1 over this value right here. And the Km is negative 1 over the x-intercept, so it's over here. Well, we can calculate those values, and let's go ahead and calculate those values. Let's go ahead and create a little table right here. Right here it looks good. Type wild type. And we'll do y-intercept. Oops, we misspelled that. And we'll do x-intercept. Okay, so I calculate those two values. And remember the y-intercept, we've already done that before, is equal to intercept. And we have to put known y's and known x's. So what we'll do here for wild type, the known y's are here. and then put a comma, and the known x's are here. Hit enter. So we have that value. I want to go ahead and that value there. Now we're going ahead and we want to do the x-intercept. Now the x-intercept is a little different. If you're used to using a calculator, this will be unnatural. You put the known x's first, which are these values, comma, these values. Hit enter. So it'll be minus 0.12. And we know that the Km is going to be the negative 1 over that value. So that should be, we should think that should be a negative number. Now we'll go ahead and do the same things for mutant. I'm lazy, so I'm going to copy, paste those things. I hit there, type intercept. It's known y's. This is y-intercept. So it's known y's, which is these values here, comma, known x's up here. Hit enter, so we have that value. Let's go ahead and do this one, is equal to intercept again. Remember, we're going to put them in backwards. We're going to put x's first, comma, y's. Hit enter. And let's make these all 4 decimal places. Oops. Okay. So we have these values. So we have the intercepts now determined. Now let's go ahead and do a little bit more work and do Vmax and Km. We'll go ahead and copy those values to here. And you notice why I line everything up. Okay, Vmax. Okay, if you see things are still highlighted, just do Command or Control D, and the little boxes will go away. So Vmax is going to be equal to 1 over the y-intercept. So it's 1 divided by that intercept. Hit enter. So we have that value. Km is a little different. Is equal to minus 1 divided by the intercept. Hit that enter, so it's 8.5. Now we do the same thing for Vmax for the mutant. Is equal to 1 divided by this value. Hit enter. And this will be equal to minus 1 divided by this value. Hit enter. So here, what you've done is you determine the kinetic values that you need to do for your report. And go ahead and you'll be doing a second one. What I would do, just to show you a quicker way to go about doing this, you notice I have all these references in here. What I would do is I would copy, Control C, create a new sheet, and hit Control or Command V and copy it all in place. And when you have that new data from the other experiment, just copy it into this place right here. It'll recalculate everything for you. And so you can, and the nice thing about it is it'll automatically calculate all of these values for you, and you'll be able to look to how similar they are, how they're not, and determine how to present that in your final report. I hope this was useful to you. The video is a little bit long, but I think in about 35-40 minutes you should be able to do all these calculations. I will see you later. If you have any questions, come by the lab during lab time, which is noon to 4 o'clock Tuesdays and Wednesdays, or if you can come by my office hours, and if none of those times are convenient, set up an appointment, and we'll walk you through anything you need to know. I will see you later. I hope this is useful. We'll see you. Bye.